For this exercise, we have a packet tracer file where some things are already configured. For example, IP addresses on computers and routers. This frame relay cloud is configured as well. Pretty much everything we're missing is OSPF and HSRP. I want to mention, though, that these computers are using address 192.168.1.1 as their default gateway IP address, and it's the same on all three computers, but this address is not configured anywhere yet. So let's start with OSPF. First, I'm going to start from router 1. And what we need to do here is advertise in OSPF all the networks that are directly connected to router 1. So let's say enable configure terminal, router OSPF 1, network 192.168.1.0.0.0.255, area 0. Next, I want to advertise this network up here. It's 192.168.2.0, and then wildcard is 0.0.0.7 because this one is /29, area 0. And yeah, that's it for OSPF on router 1. I missed to tell you the IP address configured on router 1 on this interface Gigabit Ethernet 0/1. It's, as you can see, 192.168.1.2. So 192.168.1.1 is going to be the virtual HSRP IP address that is going to be used as a gateway IP address. On router 2, we have 192.168.1.3. So let's configure router 2 with OSPF. Enable configure terminal, router OSPF 1, advertising networks 192.168.3.0, that's this network up here, 0.0.0.7, area 0, and then 192.168.1.0.0.0.255, area 0. And that's it for router 2. Moving on to router gateway. Enable configure terminal, router OSPF 1. Let's first advertise this subnet over here. It's 209.0.232.0.0.0.7, area 0. And then 192.168.2.0.0.0.7, area 0, and then just switching the third octet from 2 to 3. And that's it for router gateway. Moving on to router telecom, command line interface, enable configure terminal, router OSPF 1, network 209.0.232.0.0.0.7, area 0. That was pretty quick. We can see that OSPF neighborship has been established. And now I want to test a bit of connectivity. Just to make sure we're all on the same page here, we are going to use router 1 and router 2 as HSRP gateways. But I kind of thought that was clear from the architecture of this. But yeah, router 1 and router 2 are going to share that one virtual IP address, and that virtual IP address is going to be 192.168.1.1. So that's the gateway address given to these PCs right here. But if we tried to ping someplace from those PCs, for example, up to router telecom, that's going to fail. And that's because these PCs don't have any connectivity to their gateway. because these routers right now are using 192.168.1.2 and 192.168.1.3. We need to configure HSRP in order for that IP address to appear in this network right here. However, let's test a ping from router 1 to telecom. That's successful, and then router 2 to telecom. That's also successful. Now, HSRP is actually a pretty straightforward configuration. As I mentioned in the explanation video, HSRP is configured on the interface, which is going to be the gateway. So we need to get into interface gigabit Ethernet 0/1. That's the interface on router 1. That's this interface right here. And then we're going to use this keyword standby. That's the HSRP word for HSRP commands in Cisco. We're going to say 1, that's our group. And then we're going to specify this virtual IP, 192.168.1.1. As soon as we have configured one command in HSRP, the process will start, and we will soon see a message saying that this router is now the active router. It might take some time, so I'm just going to click fast forward here. Here we go. Okay, we went from speak. Speak is an HSRP state in which the router is pretty much looking for any other router with a higher priority. So we can say that we can see that we first went to standby and then from standby to active, which is a good thing. So let's continue with our configuration. I'm going to use this command do show standby, which will show us some details. So we can already see this address. We just configured that, and we can see the priority. So default priority is 100. And I want this router, router 1, to be the active gateway router. So I'm going to give it a higher priority than router 2. Router 2, we're going to leave it at 100, which is the default. But for router 1, I want to say standby 1, priority 105. By the way, this number 1 is the group or instance number, HSRP group or HSRP instance number. You can have up to 32 HSRP groups per router, but we're going to have only one, and it is actually important to always use the same number when you're configuring a single HSRP instance. Okay, we have now changed the priority. Let me issue this command to check. We can see that priority is 105 and that we have configured 105. The reason that we see it like this is, as I mentioned, priority will go down if something happens to this router. Well, actually, it won't always go down. For example, if this interface fails, the priority is not going to go down, but this router, in that case, will not even be connected to this local area network, and therefore router 2 will assume that he is now the active HSRP router, but the priority will stay the same. We will track this interface right here, and in case that interface fails, this priority number is going to go down to 95, and we will see that later. So let me continue with the configuration. What I want to configure next is preempt, and then track gigabit Ethernet 0/0. That's this interface right here. So since we're configuring HSRP on this interface, which is gigabit Ethernet 0/1, obviously if that interface goes down, then this router cannot be the active router anymore. But we also need to tell HSRP which other interfaces are important to us. So which other interfaces, if something happens to them, change the picture here. So we do that by issuing this command. Okay, now we can go back to router 2 and say interface gigabit Ethernet 0/1. That's the interface between router 2 and switch 2. And then let's say standby 1, IP 192.168.1.1. I'm going to also say priority 100, even though that's the default priority, but let's use the command just to remember it. Standby 1 preempt. But I'm not going to track any interfaces, so we will see later how that makes a difference. And that's it. We can go to testing now. The first thing I'm going to do is I'm going to remove this link, and then make sure to press the escape button on your keyboard so that you don't delete this router when you click on it to check what's going on. We can see that the HSRP state has changed immediately from active to init, and soon it should go, well actually on router 1 it might not even go to anything else because it's not connected to the second router, but we can see that on the second router that it's now active. So that's what matters. If we look at the communication, which we haven't tested before though, but let's test it right now. So PC1 to router telecom is successful, and the packets are obviously going this way because there's no other way around it. Let me briefly issue this do show standby command, and we can see that state is init, interface is down. This is the reason to this is the reason for this state to be different from active. Priority is 105. Standby router is unknown because we're not really communicating to that router through the interface where HSRP is configured. So yeah, that's the situation. I'm going to bring back this link. It's gigabit Ethernet 0/1 on both sides. Go fast forward a couple of times. And we can see this message here that we went back to active on router 1. Next thing we want to test is we want to remove this link over here. And this connection is actually tracked by HSRP. So we want to see what happens there. Okay, HSRP hasn't said anything yet. Okay, now it has. This one was actually slower than the previous example. So yeah, this router is now standby, and then router 2 is now active. Let's go to show standby. This time we can see that priority went down to 95 and that configured priority is 105. All right, I'm gonna bring back this link, gigabit Ethernet 0/0. And then what I'm gonna do, if I just removed this link over here, nothing would happen because this router is the standby router anyway. So I'm going to increase priority here. I'm going to go to interface gigabit Ethernet 0/1, standby 1, priority 110, because 105 is the priority on router 1. And as you can see, this change was pretty quick. Okay, so we're not tracking this interface up here, and I want to check the connectivity before I do this. Okay, it's successful. Now let's remove this link over here. Let's look at router 2. So interface down, but still nothing is happening with HSRP. If we go to do show standby, This router still thinks it's the active router, and priority is still 110. And if we try to ping from PC1 to router telecom, it's gonna fail. Oh, so now it found its way. Let's see how this goes. Okay, so it's going to router 2 because that's its gateway, because this router is still the active HSRP router. And then this router, since it's connected via OSPF to this router over here, and then to this router over here, and this router over here, it's going to actually route that packet through router 1 to router telecom. But that's not an ideal situation, which is why we should use this track option. Okay, I'm going to bring back this link. And again, nothing happens because we did not configure tracking. I'll leave you to play with that. And in the next exercise, we're going to do something even more exciting with HSRP. So see you in the next exercise.